Okay. Good morning, guys. In this lesson we will continue with the operator overloading on the on Python programming language. We have the slice property to be overloaded in the function definition or the class definition. Okay, for example, in the slice operator, this list structure or the tuple structure can be reached by using the 3 to 5. Okay, but the Python interpreter interprets this code like this one in this notation. Okay, and so we can create the class myArray definition like this one, and so we can give the def init function with the a and no return values in here. Self a can be assigned with this term, and then we can assign the get item function self, and we need to get the index values of this array. Okay, and so firstly we need to control the type of the index here like this one with the slice operator, and then we should write to the return of this list values self a I for I in range with the index in this is len self a. Okay, so we can check all the terms in here with the specific index, for example 3 to 5, and so we need to create the for loop in here like this one, and so the 3 to 5 if it's satisfied, and then we can return these values. Okay, and after that we should give the self a index as a slice, and also we can assign the set item function in here with the parameters of the self index and val value if is instance index and slice, and so we can assign the k0 for the assignment of these terms, and after that the for I in range can be given in the index as an argument like this one in this is, and the self a, because we have the 3 to 5, and so we have the 3 elements in here, and after that the self a I can be assigned with the val k. Okay, and k plus equal 1, and so 3 to 3 4 5 can be assigned these terms, and after that if this is not the case we can give the index values like this one. Okay, while so also we need to create the len operator in here like this one, to return the self len self a function, and also we can overload the str function, the parameters of the self, and the return str self a. Okay, these are the overloading mechanism for the slice operator, and we can test our class like this one, the ml myArray with the terms of the 1 2 3 4 5, and after that we can assign the result value with the ml 3 to 5, and we can print the whole results like this one. Okay, in the terminal we have the 4 and 5. Okay, 3 4 and 5 assigned. For example, the 30 50 20 10. In order to be sure about this function is called the get item func can be assigned in here, and also set item can be represented like this one. And so only the get item func is called by the Python. Okay, and also we can assign the ml3 body in here, and we can print the whole the results like this one, the 40. But also we can assign the 3 to 5 to what, the 100 and 200. And also we can give the what, the print ml function in here, and the set item func is called by the interpreter. Or we can assign the ml3 terms like this one, the 1000s, and we can print the ml. Okay. Or we can assign the only integer values. So if we have this property, and then we can overload the myArray function or the class to what, to perform the this slice property, or we can reach the whole data by using the what as a sum the range values of our algorithms. Okay. So we need to talk about the type conversion in class structure. Firstly, we can define the number class in here with the constructor values of the what, the self and while, and we can print the init function. Okay, this is the warning for the what, the calling operator for the what, constructor values. Okay, and so self while can be assigned with the while. Okay, and so type conversion can be overloaded in here with the what, with the specific name of the types. Okay, self print int func is a warning, and we can return to the what, the integer values of the what, self while. Also we can overload the what, the float, the basic type of the Python, with the parameters of the what, the float func, and we can return to the what, the float, self and while. Okay, and also we can give the boolean value, boolean conversion. We can print the bool func and return to the bool of the what, the self while. Okay. Also we can convert the whole the terms into the what, the complex number, self, and we can print the what, the complex func, and we can return to the complex self and while. Okay, these are the basic definition of the what, the type conversion class. And so the n number can be assigned with the what, the 20, while integer value n can be called in here, and we can print the while value. Okay. If this is the case, then we can obtain the what, the init function, because this is the constructor, and this constructor is called by the Python, and then this warning is given in the what, in the terminal page. After that we can convert the integer value with the parameters of the n or the number constructor, and then we will get to the what, the print function in terms of the what, the 20 values. Okay. And also while can be assigned to the what, the float like this one, while, and also boolean conversion can be done, print while, and also can assign to the what, the complex values, print while. Okay. So in every time we can change the type of the what, the while or the number value, and then we can assign to the what, to the other terms. Okay, but just remember that this float is a separate class, but the number possess this function, and so this function overloads the properties of the float and bool and complex number, which means that this float is applied on the basic types whatever you are using the type. For example, you can convert the integer values to the boolean one, or the string value convert to the what, to the float one. But if you don't have this function or this definition, and then we cannot do that, okay? Because this int is also a class, but basic type of class, okay? You must be write all the overload for your own class definitions. In the 13th example, we should give the what the I add function, which means that a equal to the a plus 1, okay? In the first term, we can create the instance of the any class or our own class, and then we can add the one value in here, but with the what, with the utilization of the I add body. For example, we can define the another number class in here. The init function, self and while can be given, and we can print the init func, okay? So self while can be assigned to the while, and after that we can overload the add body self x in here. The print add func can be given, and we can return to the new variable in here the number self while plus x dot while, because the x is also a what, a number instance. We have the I add function, self and x, okay? The print I add func, and we can return to the what, number of the self and while plus x then while, okay? And also we can obtain the wrap r function in order to write the whole the terms in the overloaded form, and so we can give the self and print to the what the wrap r func return str conversion can be given, and self while is applied, okay? So in the first place we can define the a as a 10 and b is a 20, okay? A equal a plus b. If we call the a function in here like this one, and so the double init function are called because we have the a and b instance in here. After that, the add function is given at this place, a plus b, because this is identical with what the a add with the parameters of the b, okay? And after that, the wrapper function is given because we can call the what print in here like this one. But what's the difference between the I add and add function? Firstly, we can define the another variable in here like this one, and this is for example a plus equal to the b, okay? And so if we print the a function, and after that in this case we have the I add func body, okay? And so this is also given with the what the plus b, okay? This is the a I add with the parameters of the b, okay? Just remember that. So we should define the another application file in here, Python 2, and after that we should give the what the another topic with the name of the what the static class and methods and functions. What's the static class and functions? In Python, some methods can be used without creating any instance of class, which means that this class are utilized to do what? To only a specific purpose, but we don't need to what to create any other variable or any other class. And which means that the only methods are required for the specific purpose. Okay, at this time we can create the static methods. Nerede? Or where is it? In the class definition. This is called in the later case the decorator in Python programming language. Okay, and we can build the example session about that. For example, if we have the date class in here with the initialization function of the self, the month and the year, and we can assign the self day is equal to the day, self month is equal to the month, self year is equal to the year. Okay, and so how can we create the static methods? We have the add operator in here like this one, and we can define the static methods by using this declaration. And after that we should give some specific code below this definition. Okay, for example, the checking the leap years in here, leap year, the definition of the year, and we can return to the what the year percentage or remaining tool is equal to 0, or year percentage 4 is equal 0, and year percentage 100 not equal to 0. Okay, the self is not used in this case. Just remember that in the static methods we don't need to define self, but in the other case we need to give this self to the date, because the self should be contained at every method or the function in the what? In the class samples. Okay, but if we have this declaration in here like this one, and then we don't need to utilize or creates the self parameter. Okay, firstly, result can be assigned with what the date is leap year 2000s. For example, the print leap if result else not leap. Okay, this is the standard case for the what the result is the leap or the true, and then the leap is written, otherwise not leap. This is the leap, but if we have the 2001, and so this does not leap. Okay, the other example can be given by using the class date like this one, def init self day month and year, and self day assigned with the what the day, self month assigned with the month, self year assigned with the year. Okay, and also we can give this function, but this function should contain with what the self parameters. Okay, the print open and closes fancy parentheses in here. This is the standard date notation for the what, for the self day, self month and self year. Okay, and also we can give the what the static method by using this definition. Okay, this is the same with the previous one. I can print these values in here. Okay, we don't need to have any related data for the instance, but this results or date can be defined with the date parameter 16, 5 and 1991, and date disp can be called or date disp function with the argument parameter of the date. Okay, so what's the difference between these two codes? Firstly, this date is an instance, which means that it has the specific address of the what on the RAM. Okay, and so this date can be called with the this parameter because this date possesses the own self body. But you can use or you can call the class date.disp with the parameters of the self. Okay, and so which means that this is the specific address of the each instance, and then this is like used for the like the static methods. Just remember that. Okay, or can use the result with the date parameter like this one, because the is leap year should also be contained in the date instance 2000s. Okay, we can print this value like this one. So each class should contain the specific properties or the specific address values of its own, but we can call the date.disp function by using these terms. Okay, so we can create the def sample class in here with the self parameter, and we can print the foo value. Okay, and also we can give the static methods def bar with the parameters of the self, in this case bar. Firstly, s can be defined in here like this one, and so there is no syntax error, but this bar possesses the self parameter. Okay, but as foo function, if I call this function, we get the foo, but as bar with the 10 is also correct in here, because this self is not the self of the class. This is the any other parameter, or like, for example, like the a or b. This is not indicating to the class sample parameter, because this self is contained in the foo, and so we should not give to the foo as a simple parameter or any parameter, because the self is a hidden parameter in here, but the s bar is not. And so what happens if I call the bar without the arguments? And so we have the error, because the sample bar missing one required positional argument, self, which means that this self, like this one, bar a or bar b. Okay, so in the static methods, if we have the self parameter or with the name of the self can be given in here, but this is then arbitrary arguments for the bar parameter. Okay, so this is the syntax error. So the static methods can be defined by using these terms, but we also have the class methods, which means that if I define the sample class in here like this one with the init parameter self, okay, so the self a can be assigned with the 10, and def foo, the self, the print foo is given. Also we can define the static methods. Okay, def bar, print bar, or def tar given the tar. Okay, So a sample can be given in here. There is no syntax error. Just remember that this static method is declared in here, and so this static method contains the what, the tar and bar value, and we don't need to declare every function to these keywords. Just remember that. But we can call the foo function like this one, okay? But also we can call the sample body bar and tar, okay? We don't need to use the positional arguments in here. But if I define this term, class method, and after that if we can call this term, and so sample tar takes 0 positional argument but 1 was given, which means that this property must contain the CLC arguments like this one, but we don't need to utilize to the tar body in here. For example, if we have this definition, and so we can call the S bar and S star with the what, with the without the positional arguments given in the what, in this notation, okay? We can define the class method also by using the what, the class method keywords with the what, the CLC parameters. So any question? If there is no question, we can give the new topic in here like this one, decorators. What's the meaning of the decorator? Decorator means that the conditioning, the function and classes related to specific features, okay? We can define any class with the name of the add_foo or class method. This is called the decorators. We can specialize whole the class by using this definition. For example, we can define the def_foo with the parameters of the a, and so we can print the what, the foo function, okay? And we can return to f value. And like using the what, the static methods or the class methods, we can define this foo function as a decorator, which means that we can define the bar function like this one, and so the print bar value can be given. And also we can define another bar function, print bar, okay? And so what happens if I call this function like using this one? If we have this utilization, and then there are two foo is given in here, because this foo creates this one, okay? And so this foo take the parameters of the bar, because this bar is assigned with what, the decorators of the foo, okay? And so this parameter is taken this one, and then we can assign to the what, the new values or the new address values of this function operator, okay? And so in summary, the decorator function is called when we call the decorated function, which means that if we call the one function, and so this function calls to another function by using this declaration. For example, in order to clarify our example, we can give the what, the internal code declaration like this one, def_foo f, and also we can create the what, another function within a function, the print internal code, and also we can call the f body, and we can return the g, okay? And def_foo can be defined in here like this one. We can also define the bar, okay? And so what happens if I call the bar function? In normal case we call only this one, and so which means that this bar is seen on the what, on the terminal page. But if we have this code, the internal code is also called by using this term, because this bar is decorated with the what, with the foo function. And so this foo function is also given in here, like this one. Print internal code is seen, and we return to the what, to the g values in here after the what, after the these terms. And so this g is called the print function, and this f is also given in the what, in these terms. Okay, and so this bar is taking automatically arguments parameters with the what, with the function values or the function address, without usage of the any arguments in here. Okay, and so this two function is the what is related to the each other. For example, in the applications, we can create the log operator in here, datetime as dt. Okay, and we can define the mylog function definition in here, like this one. Can create the file, open log file txt within a writing operator, and we can create the def log, and we can write the file write function code. Okay, add plus str dt date time, and now this is the time of the now, and also we can give the what, the new line character. Okay, and we should take the what, the f function, or call the f function in here, and after that we can return to the log value. And so what happens if I run this code or define this code? For example, at my log can be created in here, like this one, def foo, and print foo is assigned with this term. So what's the decorator? If I call foo, and then this foo creates the what, the log file in here. Okay, function called at blah blah blah. But if I call 3 times, and then we have the 3 terms in here, like this one, at this time, and so we have the 3 calls in the function body. And so this foo is related to mylog, and then we can count the how many times foo are called in the what, in Python process. This is the basic utilization of the this decorator, but you can specialize this function by using the another purpose. Okay, just remember that. Any question? Decorator class can be assigned to the another one. For example, class foo can be defined in here, def init, the self f. Okay, the print first process can be assigned, and self f is equal to the f. Okay, and we can overload the call function. Just remember that this is the calling function operator, like this one, the print internal code, and self f is assigned with the f. Okay, this like in C or C++ programming language, the lambda expression. Okay, and so at foo def bar, the print bar can be called, and bar can be called. Okay, and so if I call the bar function, this bar function is related to what, the foo decorator or foo class decorator. And so this foo class decorator creates the what, the pattern, and calls this function. For example, if I have this code, and so first process is seen on the what, on this page, and after that the internal code or the function calling operator is overloaded in here, like this one, and after that we can see that the bar definition. Okay, and so this is the simple syntax for the what relating to function to a specific purpose of the class properties or the class methods. Okay. So how can we decorate the class? Firstly, we can define the foo c and print foo function can be given, and so we can return the c values. Okay, and add foo, we can assign this body like this one, the class sample def. This function can be defined and can print the what this body. Okay, this foo is assigned, or this sample class is assigned with what the foo c. Okay, so if I call this sample body like this one, and so foo is automatically called, and also we can call the this function like using this one. Okay, this is what we can define the class sample in here. But in the later lesson, or in the next sessions, we will always utilize this decorator class or decorator function in order to what? In order to build your mechatronic applications or some specific purposes. Okay, so any question? Okay.